All right, people. Hello, everybody. Nice to see you again. I don't know if I remember how to do this. Hopefully the volume is okay. Hopefully the technical aspect of the stream is okay. I haven't streamed in a minute. I have to admit. Might be like way over a year. So I don't know how it will go. Hello, everybody. My name is Gianpaolo Vernocchi. I am the director of Destiny Bit, which is an Italian studio that is making a crazy game called Dice Legacy, which is a city builder set on a ring world, and it's all powered by dice, of all things. It is made in Unreal Engine 4, and since it's a game set on a ring world, it actually has a lot of very interesting technical, let's say, aspects that are interesting about it, and a lot of different solutions that we had to find. A lot of the things that normally work on, let's say, a flat world don't work over here. So today I have a list of topics that I have wrote down. This is going to be the first stream in a series. I don't know exactly how many I will do. There's really a lot to talk about. I will try to keep these streams around an hour in length. I will try to interact with the chat as much as possible. If you have any questions regarding the project or the techniques that we used, feel free to ask them. I will try to stay on topic. And so please, let's try to talk as much as possible about Dice Legacy and what we're doing. And what else? Yeah, I think we're ready to go. So I will now jump into Unreal Engine, and we're gonna start to look at some things. Here we go. All right. So here we are inside of the engine. By the way, for those of you who don't know what Dice Legacy is, Dice Legacy is a dice-based city builder set on a ring world. So basically, the dice are representations of your people. You can use them to collect resources, build buildings, defend your settlement from attacks, and it's a survival city builder. So eventually, we'll have to survive attacks from mysterious forces, survive the winter, and whatnot. It is built in Unreal Engine 4, like I said, and it's a pretty interesting game. So back on the engine, I'm gonna launch the game. By the way, keep in mind that this is a game under development. Uh-oh, my connection. Like I said, keep in mind that this is a game under development. So what you are seeing right now is the current status of the game. So there's going to be bugs, there's going to be weird quirks, and for example, the UI is all temporary. So keep in mind that it's not going to be super smooth, but you get to get a peek behind the scenes, let's say. So first thing first, we are on Unreal Engine 4.23.0. So we are a couple of versions behind the official release of Unreal Engine. This is largely untouched, as in the Unreal Engine version. We did a couple of tweaks recently to it, but this is mostly a vanilla version of the engine. So I'm just going to hit play for a second, and we're going to take a look at how the game plays. So there we go. All right, so like I said, the UI is temporary, so don't pay too much attention to it. I'm gonna keep it as much as possible on the technical side of things. So the first thing that you're gonna notice is that we are on a ring world. So the world is a cylinder, and that there is a day-night cycle happening. So the sun is moving, and we are on a ring world, which means that at the same time, there is a portion of the ring that is under the sun and a portion of the ring that is shaded. And if I now open the cheats menu and move the time of the day slider, you will see that over here the light is off. But if I move the sun, the light gets turned on as the buildings get into the shade, get into the night part of the world, let's say. And this is all happening dynamically. So again, I'm gonna cheat a little bit. I'm gonna give myself a bunch of resources and a bunch of dice so I can place a house. The game is on a hex-based grid, although in the beginning we were trying a more freeform approach to it. We then reverted back to a hex-based grid because it is better for interactions, saves us a lot of headaches, and in general we felt it streamlined the game a lot. So right now I'm gonna place a house, let's say over here, and I'm gonna build it. So this happened super fast because I'm cheating, but normally there is a whole animation that I'm going to show a little bit later. So you see that this house has its lights on, and this house has its lights off. But if I move the sun, this one gets... the lights are being turned on. So this is one of the first things that you will notice about the game. Another thing that you will notice about the game is that we are on a cylinder. So if I... let's say, set the time of day, and then I detach myself. So this is what the world looks like inside of the engine. So basically, we have a mesh over here that is all the terrain. It's a static mesh. It doesn't have anything particular about it. The shoreline is actually hand modeled. We have literally no reason to do anything fancy with this cylinder, so it's just a cylinder. You will see that the gameplay takes place only on half of the cylinder. This is mostly to keep the action contained and keep the game fast. But this helps us quite a bit, and you will see it in a second when it comes to various things. You will see that now. Don't pay attention to this like fighting between the fog and the sea, but you will see that we do have a fog, for instance, and you will notice that the fog is actually cylindrical. I'm gonna remove the fog of war for a second because there's also a fog of war aspect to the game, but you will see that the fog is cylindrical. This was one of the first challenges that we had to solve, which basically means, okay, Unreal Engine gives you let's say it gives you like atmospheric fog and stuff like that, but we couldn't use any of that because that's all for a flat world, and we don't have a flat world. We have a cylinder world, a ring world. So we had to come up with our own fog solution, and I will show it to you in a second. You see that we have some rocks on the sides. These rocks are an instant static mesh. With a bunch of instances. This is the same rock repeated over and over again, which just essentially what I am doing is I believe I am randomly flipping it on the X side and Y side just to give it, well, on the Y side just to give it some randomness, and it's just placed over and over and over again, and yeah, it's just a bunch of instances of the same mesh. Same thing goes for the asteroids. The asteroids are also an instant static mesh. It's actually multiple instant static meshes. It is one for every different asteroid. So you can sort of like tell that we have like 4 rows of asteroids. There's the first one over here, there's the second one, there's the third one, and there's the smaller one. So we have 4 rows. They start pretty big and then they get smaller and smaller. And these are all essentially 4 instant static mesh. And we use the same instant static mesh for both sides. So the big rocks are over here and over here. And this is the same instant static mesh. And what I do is in the material, I rotate them individually. And we rotate the whole mesh to simulate sort of like this gravity thing going on. I will show it to you later in a second. You can also see that we have clouds. going on. But again, we can't do regular clouds. We can't do volumetric we could do volumetric clouds, but that would be weird. So what we have is these circular clouds that I will show you in a second how they're done. These are pretty much inspired by the concept art for the game that you can see on Steam, and you can see on the basically everywhere for the PR of the game, made by the wonderfully talented Scott Pellico. You can see that there's people walking around, and these people are walking on the cylinder. So another interesting thing to solve for us was, how do we do pathfinding on a cylinder? You can see that there's plants moving with wind and whatnot. And if I go back to the screen, like to the in-game scene, you will see that I can go up into the cylinder, and everything still makes sense. Everything is still shaded somewhat coherently. Ignore the fog of war over here. This is work in progress, but everything is working out just fine. You can see that we have foliage on the ground. And another thing that you might notice is that if I place a house, the foliage gets eaten away to leave room for whatever information the house has to display. So, for example, here we have a slot where we can place some dice. So you can see that essentially the grass is gone away. And I can add the dice there, and the grass does not occlude the slots. Another interesting thing, I'm going to stop the sun for a second. Another interesting thing that you might notice is that we have a bunch of effects. For instance, when I place a building, you see that the building pops up from the ground, right? And this works everywhere on the ring, over here, and it works over here as well. It doesn't matter the inclination of the building. You can see if I eject again, that stuff over here is pretty plain, but stuff over here is pretty much hanging 90 degrees, right? From the in-game view, everything looks the same to the player, and this is kind of the beauty of the ring world. By the way, hello, Nakamura, Gunschlinger, Apollon. Happy to see you guys. So, essentially, inside of the ring world, to the player, everything appears the same, but actually, we are upside down at the moment. As a matter of fact, if I detach on the Unreal camera right now, the Unreal camera can't really keep up with me. If I rotate it, I get into some weird gimbal issues where I swear I'm not trying to make this difficult. This is just how the camera rotates when you essentially start from like upside down. It's kind of weird. So from the game view, nothing happens. The reason for the ring world, by the way, if anyone is wondering, we were searching for a way to minimize camera movement. This game plays very much like a board game. So you have the stuff in front of you, and you are placing dice, you are placing buildings and stuff like that. It's a very physical game. The problem was that the camera was always in the way. The camera was always in the way. Like, you had to move the camera, move your stuff, do your things, move the camera, and we wanted to minimize that as much as possible. So initially we were researching an idea of just doing sort of like a blackjack table. If you're looking down on a plane and you're looking left and right, and then we said, well, we might as well curve this world a little bit so that you can keep your eyes on everything, because the beauty of the ring world is that I can see these icons over here pretty clearly, but I can also see this icon that is way over there very, very clearly because it's pointing at me. If this was a flat world, that icon would be much, much smaller, and it would be much more distorted. Instead, we are showing the player everything, right? So that is pretty interesting. And so the idea for the ring world came from our concept artist, again, the amazing Scott Pellico, who just simply put the camera on a ring, and it was like, why don't we do a ring? And that made so much sense that the whole game was redesigned around this idea. And that also meant that we had a bunch of interesting solutions to find everywhere. So, basics of the ring world. The ring world is standing at 0, 0, 0. The world is procedurally generated, and I will show you in a second the blueprints for that. There's a bunch of locations placed into it. The ring is 5,000 wide by, I believe, 2,500. No, sorry, my bad. It's 5,000 wide by 10,000. So it is a perfect circle, but it's half as thick, let's say, as it is big. It is centered at 0, 0. So 0, 0 is over here. And so the town center, for example, is at... Oops, took a screenshot. Didn't mean to do that. The town center is, for instance, at minus 5,000, more or less, on the z-axis. It is 0 on the x-axis. And it's minus 300 on the y-axis. So all of these buildings, obviously, are just placed with a simple projection. Nothing fancy going on there. But anything else that has to pop from the ground or that has to be pushed into the ground, for example, like the grass when I place down a building, has to be done taking the ring into consideration. Now, the first trick that we discovered pretty quickly is this. So let me select, let's see. Let me select the grass material. So I'm going to go into the environment, materials. I should have a generic foliage material. I doubt that, I think this could potentially work on mobile. It would require a little bit of a redesign and a little bit of a toning down of the effects and the graphics. System requirements are pretty basic. This is definitely not CPU intensive. The game scales quite well, and I will show that in a second. We are also doing a bunch of stuff for scaling. But I don't know about mobile, but we are targeting Switch. So technically, if Switch is doable, mobile is technically doable. So one thing that we discovered pretty quickly is that we have a trick up our sleeve that we can use everywhere, which is... let me see if I can find it. There we go. Here's a perfect example. We have this, okay? Take a look at these 4 nodes in the material. These 4 nodes allow us to push anything away from the camera or towards the camera, or I would say towards the normal of the ring in a given position extremely easily. So we just take the absolute warp position, we normalize it, and then we multiply it by the same value on every axis. And essentially, if we multiply it by a positive value, we push things down. And if we multiply it by a negative value, we pull things towards us. And we use this technique everywhere. Everywhere in the game. So with this technique right here, we are pushing down the grass underneath the buildings. We are animating the fog. We are animating the clouds in a way. Or just offsetting the clouds. We are animating the buildings. We're doing all kinds of stuff. Just with these 4 nodes. It's pretty cool. That essentially allowed us to do a bunch of effects, and I will reference these 4 nodes very often during the stream and future streams. So let's take a look for a second at how the world is built. So like I said, we have a cylinder. This is just a cylinder, like I said. Let's take a look at the material for a second. This is just an instance, but let's go to the parent. Now, things are a little bit messy on this material. There's some unused nodes here and there, but bear with me. Hello, Balkern. Long time no see. So you would see that we have just a layered material. We are using material attributes. We are blending them with blend material attributes. We have not experimented with material layering in Unreal just because it's still technically a beta feature. and it's gonna come out of beta on the next release of Unreal. So development for this game started less than a year ago, so we went with what we had, essentially. And so we use this. So essentially we have just a bunch of layers. We have grass over here, mill grass, others grass. Essentially we just have different biomes on the ring. We have a standard biome, a middle biome, and a sort of like a top biome. So we have a bunch of materials over here. They're just, you know, a collection of textures. Pretty standard stuff. This is how our every mask for the world works. So you can see that the texture is split in half because this is how the ring is actually unwrapped. So if I go over here and I take a look at the UVs, you will see that basically half of the ring is on half of the texture, and the other half of the ring is on the other half of the texture. This essentially is a good way to stay on one texture and stay on a square texture and have the whole ring in it. So on the left side we have the main part of the main portion of the ring that the player sees, and on the other half we have the other portion of the ring, which is mostly just occupied by water at this stage. And as you can see, the camera in Unreal tends to go pretty crazy when we deal with a ring world. So every texture, either that we generate or that we use, that is used as a mask on the terrain, uses this trick. So on the left, we have the thing that the player sees, and on the right, we have the thing that the player does not see, and that is under the sea. No pun intended, but it was a decent pun. So, this section, for instance, is just hand-painted, okay? There's no procedural generation here. But if we go into the base world generator, this is a blueprint that takes care of a gajillion things. Over here, we generate a bunch of textures. So over here, we made our own sort of like texture factory. This textures factory is simply sort of like a manager for render targets. We have 2 render targets that we are rendering to. Sorry, 3 actually render targets that we're rendering to. One is just basic terrain. So it's static. It's not meant to change. The other 2 are actually dynamic. One we call it effects, and the other one we call it dynamic terrain masks. So at the very basic, we have sort of like soil and grass, and soil and grass are generated using a material that is then baked into a render target, and this is sort of like what it outputs. This is more or less what it outputs, and this is generated by this material right here. This material is pretty simple. It has a terrain texture parameter that is passed on it from the outside, and this is the texture that we are actually generating at generation time. So, for instance, let's say that we want to have grass underneath every forest. We can do it using this texture, and just this texture will not change ever. So we can use it in this way. And over here, we just have a bunch of noise nodes. These are very cool, very powerful, but very expensive. So the rule of thumb is to never use them in real time and always bake them. And that's exactly what we're doing. So over here, we're just baking them into the emissive, and we are baking the result of this material into a texture. This is pretty easy to do. You could do it. You could do this pretty easily. I don't remember. Oh no, this is opening Visual Studio. Don't remember exactly where we are doing it, but I believe we're doing it over here in this blueprint. I just have to find exactly where. But anyway, essentially this material gets rendered out into a texture, and the texture that is outputted, it's this one, right? So you can see that we are actually outputting multiple channels, and we're using them for different purposes. So I don't remember exactly for what at this stage. I would need to double check. Mind you, some of this stuff was done months ago. And so my brain is kind of all over the place. But this is what we're doing, and these masks we are using to generate the grass, generate the various terrain masks and whatnot. Now, an interesting thing that I'm doing over here is I'm doing a pseudo-random generation of these textures. So the maps are procedurally generated, but we do have a seed system. So this material can receive the seed from outside, and I use over here just a bunch of math to do some pseudo-randomness that I then feed into the position of the noise, so that the noise is always different every time we generate the map. But if the seed is the same, then the noise is the same. This is pretty useful. For example, let's say for save games, we don't have to store textures necessarily. We might have to, but we don't have to. This is also pretty useful in general, just to have a more consistent result. So, this is a fairly interesting thing. This seed thing. The world generation happens across many different steps. So we generate, the first thing that we do is we define a bunch of clusters. These clusters, I'm gonna kind of gloss over the gameplay stuff, and I'm gonna keep it to the technical art stuff. So we generate a bunch of clusters, which are sort of like, let's say a cluster might be a bunch of forests, a bunch of mountains and mines and whatnot. So these clusters are generated, and then we go in and generate the textures. We have a bunch of functions to write circles on a texture. This is all done by us. And this is what I was talking about, this material being fed a texture from the outside. This is where we use it. So this is what we're doing. And then we finalize, and then we have a texture that is ready, right? So over here, let's see. Let's see if I can sort of like go to the generation of the grass. Generate texture. Okay, so the grass is another bunch of hierarchical instance static meshes. We are actually using multiple hierarchical instance static meshes, and we are dividing the grass in chunks. We're not doing one full thing. We're actually dividing it in chunks, so it's easier to call, essentially. So if I remove, I'm gonna disable the fog of war. I'm gonna disable the time of day. So over here, if I freeze the rendering, okay, this is an interesting console command. If you don't know it, freeze rendering basically freezes the rendering in place and allows you to move the camera and see what's being called, basically. And so if I move upwards, you can see that there is no grass here. This also stops. But what we're doing is that we have multiple hierarchical instance static meshes that are being added, and each one of them is an individual object, so that we can control the calling better and whatnot. So these are, let me reset the rendering. These are hierarchical, so if I do view mode, is it view mode? View? I don't remember the console command. What is the console command for viewing LODs? Don't remember. But anyway, I can detach and show them to you from over here. So let me show you the LODs happening. Optimization. No, sorry. Level of detail. Mesh LODs. There we go. All right, so you can see that there's a bunch of LODs happening here. Essentially, white means LOD 0, red is LOD 1, green is LOD 2, blue is LOD 3, and so on and so forth. So you can see that there's a bunch of LODing happening on the grass and everywhere else, actually. One thing that we noticed later on was that we were maybe too generous with the with the geometry on the meshes. And so the automatic generation of the laws that is built inside Unreal helped us quite a bit. Because essentially all of these laws that we have are generated dynamically inside of the engine. And this allows us to have basically what is effectively the same mesh, the same quality, but at a fraction of the polygon. So this town hall looks the same from all the way over here that it does from all the way over here. But actually we are scaling quite a bit when it comes to LODs. So you can see that here it changed, here it changed, but I can't really tell the difference. So that helped us quite a bit. So I think it's view mode. I really want that view mode LOD operation. There we go. All right, so over here I can have it from the in-game view. So you can see that the LODs are changing, but you can't really tell when the game is in movement, right? And same thing for the grass, same thing for everything. We have LODs for everything, more or less. So that's pretty cool. Thank you, Zami. Found it. That is some pretty interesting stuff. Let's go take a look at the grass from up close. Now, getting the grass right was a nightmare, really, because this is a problem that I think every game that has a heavily top-down view has, which is basically you're looking at the terrain all the time, and foliage becomes weird. Most of the foliage solutions that are out there are kind of thought for games like, let's say, The Witcher, or games like, I don't know, Horizon, where it's like a third-person camera, and you're moving around, you're looking at the grass from up close, from afar, and from different things, but you're actually navigating in foliage. In this game, you're always afar, but it needs to look right when you look at it. So if I turn off the grass, I actually have a control to turn off the grass. You can tell that the game is flat and that it's missing something. It's kind of uncanny. And by the way, just to find this texture, just to find the right texture, it took us a long time. If you go on Steam right now and you look for Dice Legacy, you will see that the game looks quite different. Those screenshots and the footage that is on Steam, it's actually quite dated compared to what we have over here. And it took us quite a while to find a good solution for the grass. But in the end, we did find it. And what we did was essentially we have more or less the same texture on the ground and on the actual grass itself, or at least a very, very similar color. And this allows us to blend between the two pretty seamlessly and just create some noise for the player. Another thing that we are doing, I don't know if the stream is eating it away or if it's noticeable, but there is temporal anti-aliasing that is giving us a hand here. So if I go back to the foliage material, first of all, you will see that this is a mask material and it's a two-sided foliage material. We found that two-sided foliage made the rendering better. By the way, hello Spaction, nice to see you. And hello Michael Gordon Shapiro, which is the amazing composer that composed the music that you're listening to right now, which is the soundtrack for Dice Legacy. So this is a two-sided foliage material. We found that this gave us a better result with any lighting, especially when you were looking upwards at the sky. I will get back to the lighting later, showing you the challenges with that. But this is just a mask material. It's not translucent. Well, there is translucency involved with two-sided foliage, but it's not as expensive as an actual translucent material. Let's call it just like fake translucency. And it is two-sided. Yes, because it's required by the two-sided foliage. But essentially, this is the star of the show. The third temporal Anti-Aliasing. This is a node that you might have seen used everywhere in Unreal, and we found that it gave our grass a more noisy feel, at least from afar, which is just great because it makes the grass feel fuller than it actually is. We don't need as many stems. We just dither them, and they just look noisy, and it's pretty, and it's fine. So this is the start of the show, really. Other than that, it's a pretty standard grass, except for the fact that, once again, we're dealing with a ring world. So some of the techniques that we normally use to do, let's say, to move the grass around, don't quite apply over here. So normally, in order to move the grass, you either have some form of, let's say, vertex paint to signal to the mesh which parts of the mesh have to move. Or a trick that a lot of people use is to do this, basically. A bounding box based 01 UVW. What this does is it gives you a mesh aligned gradient for every one of the three axes. So if I do component mask red, let me see if I can show you this. If I preview this node, you can see that this would be one of the ways to do the grass over here, because essentially this would be cool if you multiplied, for example, the wind with this. You could say, okay, so if it's black, don't move it. If it's white, move it, which is, pretty useful. But it gets difficult with a ring world. So the solution that we found was doing 2 sets of UVs for the grass. So if I open the grass mesh, I believe it's this one. There we go. It looks kind of weird over here. Don't mind it. It looks fine in game. This is just a result of the various materials not working over here. But over here, I mean in the previewer. But if you take a look at it, and if I take a look at the UVs, you will see that on UV0, you actually have the UVs are mapped to the texture. This is pretty standard. But on UV1, there is sort of like a photograph of the grass from one side. We just took the mesh, we put it in Blender, and we just did a projection mapping from the side. And this allows us to have a gradient that goes from the bottom to the top using the UV channel number 1. So if over here, I'm the wrong material, foliage, all right? So you will see that over here, I am doing this to get a gradient. I mean, over here it looks kind of weird, but because this is not meant to be previewed on this mesh. But with this technique, I can get a gradient that goes from the bottom to the top, pretty easily, and it's consistent, and it always works no matter the rotation of the stems. And this was quite useful. So there's some other interesting stuff over here in the grass. By the way, I'm showing you the grass, but the same techniques are used across the whole game for everything that is foliage, more or less. Over here, this is just to give you an idea of what's happening here. Everything that is before this bend based on camera was a technique that we tried to bend the grass based on how you're looking at it. This is a technique that is used on several city builders. For example, I believe that it's not medieval. I don't remember exactly the name of the city builder that uses the same technique. But essentially, just to give you a summary of it, if you look at the grass from the top, the grass looks flat. And if you look at the grass from the side, the grass looks tall. And it's done essentially by bending the grass depending on the camera. We tried it as a technique, but it was too expensive. Like with these many stems from this far away, it was too expensive. It might have been that we did something wrong with it. It could very well be, but it didn't work. And we did, you know, and it didn't add anything to the game. So we just dropped it. Still here, I could technically remove this, and it would potentially just speed up a little bit the shader compiling time. But it is what it is. So far, it is off. Hello, game video, by the way. Nice to see you. So we just have regular wind. This is a material function that is done by us. There is a default one, sort of like built into the engine, which is simple grass wind. But this had some implications, something weird going on. I believe this also uses a noise inside of it. I don't remember if ours does. Yes, ours does use a noise as well. But over here, I just have more control. I know what is happening. I can control it better. I can pass the values that we want to and stuff like that. Now, this is one of the very last sort of like noise that are left into the game. There's not many of them. Like I said, they're pretty expensive. But I said before that the noise the noise node was very useful. And the reason why it's useful, it's because depending on the function that you're using, the noise function is it's not dependent on the world position. It's not dependent on wrapping. It's not dependent on UVs. It's not depending on anything. It just works. For example, what I mean by this is one issue that we were having. So I'm going to stop this and I'm going to launch it again because I want to show you the fog of war. One issue that we were having is that we have a lot of stuff that we have to sort of like procedurally align onto the cylinder, right? So normally what you would do in another game, in a regular game, let's say that you had to constantly repeat a texture across a world and the world was flat. A very easy way to do it is to use a world align texture. So world align texture. This is a very useful node. We used it all the time in the past. This essentially just takes a texture and depending on the normal of the pixel, on the normal of the vertex, it blends it. And so essentially you have a texture that is flat, a texture that is sort of like this, and a texture that is like this. So you have one texture from every side, and then they get blended somehow. This is sort of like undoable on a cylinder because you will see where the transition happens, and where the transition happens on a cylinder, on a perfect cylinder, you have smearing and distortion, and it's weird. So we couldn't use this. So every texture is sort of like aligned by hand, and I will show you later some of the functions that we're using for that. But the noise function is very useful because it doesn't care about UVs, doesn't care about anything. It's just pure computation. So it always works no matter what. So this was very useful, and we're using it for the wind. And so for the wind, we are using this, and we are using this. Which is essentially, we are just orienting the stem based on its orientation. This input data object orientation still works with individual instances of an instance static mesh. So they are all individually rotated. So we take its rotation, we take its wind, and we rotate the vector just a little bit. And we multiply it by the wind. We add them together, and we just multiply it by that UV that I showed you before, and that gives you the foliage thingy. Pretty straightforward stuff. Nothing really to see here. Things get more interesting when we get into the winter side of things, but I'll get to that later. So essentially, just to sum up, we have a bunch of instance static meshes that form the grass. Now, how do we decide where to spawn the grass? You will see that if I go into the wireframe view, you will see that the grass is actually only where the grass is. But if I place a building, the grass gets pushed down. But the grass is still there. It's just below the world. There's a bunch of stuff below the world. And with that 4 nodes that I showed you before, it's super useful. because we can just push things away out of sight, and it is just beautiful, and it just works, and it gives you a very good effect. So the grass here is just pushed down, but there is no grass here, so there's nothing. Oops, there's nothing to push down over here, which is pretty cool. So if I show you the wireframe, you can see that there's no grass over here. So the way we did this was essentially we are using the result of this material right here that is baked into the render target, and we're reading from that to spawn grass. So I will not go into detail on how this was made, because this happens in the C++ side of things. But essentially, there's a bunch of properties here that I can change. And what this does, essentially, is just reads the texture on a certain channel, looks for certain values or values above a certain threshold, and just outputs a bunch of points, a bunch of transforms. And these transforms are used to spawn the grass around, and that works pretty smoothly, I would say. So no clipping issues with taller grasses, etc. Not that we can see. The grass is just one uniform grass for the whole world. So we always use the same grass everywhere. We are using different textures in order to color it differently. So if you go into the middle biome or the top biome, you will see that there's still grass there, but it looks differently. So if I turn off the Fog of War, you will see that the grass is still here, and the grass is still here, but it's just a different color. But if I actually go up close, you will see that it's still the same mesh. There's no it's like there's no two materials, no anything like that. There are other stuff that is sort of like into the world, but the way we're pushing the grass down is that we have a separate render target where we are drawing circles for containers, and we're calling containers forests, buildings, anything like that. So let me see if I can show it to you. So if I go into the generic foliage, let me see. Yes. No. It does not read it. Oh, but maybe I have the instance. It's kind of hard all the time to go and find the actual... I will never be able to get to it. No, it's too difficult. Anyway, yeah, it's kind of hard to find dynamic textures when you are running the game. But essentially, it's just a texture that we're drawing to. That we draw essentially circles for containers. And the textures works exactly like this one and exactly like this one. So we actually have to do some manual wrapping when one pixel, let's say from the top left, gets drawn on the bottom right and vice versa. Stuff like that. Hello, Polo. Nice to see you. So, another thing that I want to show you is this. This is a material function that is a godsend. This, essentially, what it does is it takes any world location and converts it into a texel, essentially, of the texture, or just a coordinate in a texture. So it does a bunch of math based on the fact that we know where the ring is. We know the width of the ring. We know the size of the ring. We know everything like that. And again, the fact that the ring is at 0, 0, 0 is a huge helper in anything math related. So this, a bunch of math that happens over here allow us, starting from a world position. Again, over here, there's another function that essentially, starting from absolute world position, derives a map point. A map point we call a point that is actually on the cylinder. So a map point would be, let's say, a point over here, a point over here. So essentially, we can convert the world position into a position on the cylinder, and then we can reconvert that into a position on the texture. All math-based, all shader-based, so super fast. No need for blueprints, anything like that. Super cool, super fast. This little function right here, which is very specific to our game, so I'm not gonna go into too much detail into it. Maybe if there's a request, I can do it in future streams. But these couple of functions right here that essentially are summed up with world location to texture coordinates. This allows us to use a texture anywhere, and be sure that that texture is aligned to whatever we're looking at right now. So, for instance, you will see that... again, I have to restart the game every time, and when I restart the game, the generation of the world happens, and it takes a while. Mostly it's the grass generation that takes the most time, but here we go. So you will see that there is darkness underneath the fog of war, and you will see that this darkness is everywhere. So you will see that it's in the terrain, it's in the grass, it's in the buildings, it's everywhere. Now, for the buildings, we have a separate solution, but for everything else, rocks, foliage, anything else, we just simply use one render target that has all the information about the fog of war, and we use that little function so that any mesh anywhere can just use that function, plug it into the texture of the fog of war, or any other texture that has the terrain as the main sort of like driver of it, and we can use it to do whatever. And so, for example, here we use it to darken the grass, or we use it for a bunch of other stuff. Another thing that we have in the game, sorry, I stopped the game. I could have kept running. Is the winter and the summer cycle. So right now we are in summer, but through the magic of cheating, I can skip a bunch of seasons. There we go. Over here, you can see that there is the winter. So we have snow, we have snow falling. You can see that the color of the fog has changed. You can see that there is snow on top of everything. I'm going to disable the fog of war just to show you a little bit around the world. So you can see that there is snow on top of everything. Now, we do snow a little bit differently on the world compared to the buildings. Since the buildings are sort of like the protagonist of the game alongside the dices, we are doing snow on the buildings with a mixed approach of both material-based snow and the separate meshes. So you will see that there's actually 3D snow appearing on the buildings. And another interesting thing that we're doing is that the snow is calculated on a per building basis. So if I place, let's say, a barracks, you will see that the barracks starts out without any snow on it. But if I speed up the time, you will see that it starts to gradually, be covered in snow. So, like I said, we have two types of snow. And if I go close, you will see it. This is material-based snow, and it's based on the normal of the pixel. Again, normally, what you would do in a game is that you just look at the normals, and you look at which normals are facing upwards, and use that information to see if you have to color that white, right, for the snow. That doesn't work in a ring world because the normal that we have to check against is not up. It's the center of the ring. So you can see that there is snow on top of this, but there's also snow on top of, let's say, this building right here that is 90 degrees actually, right? It's completely rotated, but it does not have snow over here. It just have snow on top. I will show you in a second how we did this, but keep this in mind. So just to go back for a second to the render target thing, gonna give myself a bunch of resources. I'm gonna build a steam generator. Now, cold is one of the main things that you have to deal with in the game. So I'm just gonna place down a die to build this this steam generator. I am going to increase the game speed a little bit, just so we don't have to wait as much. There we go. So okay, this is not happening because I think I removed it from the terrain material, and I don't want to go back into it. But essentially, what happens normally is that we draw a circle around this building right here on the render target, and we use that to sort of like melt the snow around the building. Another thing that you will notice is just footprints. Footprints are pretty easy to do. Nothing interesting there. These are just decals, by the way. Just pointing at them simply because it's it's something that often people wonder how they're done. It's just simply decals in our case, mostly because the camera never goes this close. Right now, we are doing something that the game will never, ever, ever do. We are always going to be, this far away from it. So this is fine. Hello, Psycho Gaming Lab. Nice to see you. So let me show you how we did that normal trick. But I'm going to speed up the game just to show you a little bit of the transition. I'm going to go and set it to 20. Time dilation. This is how the transition between winter and summer happens. Essentially, we just start to melt down the snow. And the snow melts everywhere. And then we are back into the summer. And the cycle repeats again. I'm going to skip to the winter again. Simply because I want to show you very quickly the snow falling. Snow falling is pretty simple. It's just a particle system. Let's see if I can select it. Yeah, there we go. It's simply a particle system with a cylinder emitter set in local space. Everything in this game is in local space when it comes to particle systems for obvious reasons, because they have to work no matter the rotation. So it's just a particle system set with a cylinder, and it just happens on half of the world because we don't need ever snow here on the back. By the way, a lot of the stuff that you're seeing is the result of many iterations and me going back to it and looking at things and not liking them and redoing them. And, when I look at for example, when I look at the screenshots that are on Steam, there's a lot of stuff that I hate about them. And you will see that I changed many of it. For example, the way the snow falls and the way the snow accumulates is totally different. Right now, it's this more natural look where sort of like snow accumulates over time. Before it was sort of like this like liquid kind of deal, which was weird. And a thing that bothers me quite a bit is the water. I don't think the water looks particularly good at the moment, and I will return to it later. Again, the water has issues because we can't use many of the techniques that you normally use for water, so we have to be careful. But anyway, so let me go back and show you that normal thing that we do on the snow. So anything in the game that uses the snow for it's like uses the material snow. So I'm gonna open a building very quickly. Let's say I'm gonna open one of the most recent ones. Let's say the Alms House. All right. So this building right here, every building in the game uses an instance of the same material. All the buildings use the same master material, which is now a behemoth of a material with a whole bunch of dynamic parameters. So if I go into the material, we'll see that it is It is not too crazy, but the reason why it's not too crazy is because a lot of the stuff is hidden behind material functions. And one of these material functions is MF snow effect. This material function essentially takes an input, the amount of snow, which is just a value between 0 and 1. The maximum amount of snow in case we want to not go too crazy with certain stuff, or we have to tone it down for, let's say, forests, or depends on the geometry of the building as well. So we feed the base color, we feed the masks, we feed the vertex color red in case we want to exclude certain portions of the mesh from having snow on it. And then we output base color, occlusion, roughness, metallic. Hold on. Windows is going crazy. The night shift colors kicked in, which helped me sleep. I encourage you guys to enable this. This is night light. It's built-in Windows. It makes everything yellow, but it makes it so that your circadian rhythm is not so broken by you working late at night. But maybe not very pretty on the stream. So let's turn that off. It's not so yellow anymore. So like I said, this outputs base color, occlusion, roughness, and metallic. So pretty easy for me to go out of this function. But if I go into this function, it's actually fairly easy. We just blend with the base color and the masks from the material, the base color and the masks for the snow. Instead of doing simply checking the dot product of the pixel normal with like a Z, which would be 001, we use, once again, the good old four nodes that I showed you before. So these 4 nodes, dot product is essentially now I might be explaining it wrong, but just bear with me. Essentially gives you tells you how similar two vectors are in direction. Essentially we do the dot product between absolute warp position normalized multiplied by -1 and the pixel normalized, and essentially we get a mask that is 1 when it's looking upwards, and it's 0 when it's looking not upwards. I do a bunch of power here just so that I can get a smooth transition, just going from 0 to 1, so that snow accumulates over time. Essentially what I'm doing here is just I'm doing a curve on it, and that allows us to do snow, which is pretty cool. Now, there's a bunch of other stuff that I want to show you. This stream is already about an hour long. I will show you a couple more things, and then I think I am going to call it a day for today, and I will come back with a new stream, possibly even next week. So the other couple of things that I want to show you is a couple of things related to lighting in the skybox. So this is a skybox that we're using. It's a Galaxy. It's okay, I would say. It looks okay, considering that in the game, when you are in the game, you just see little slithers of it on the left and right, so you don't see a lot of it. But this looks pretty good. The material, this is just a sphere, okay? Just a sphere with the normals inverted, unlit, and the material is this. So what the material is just a bunch of channels in a texture that are being animated in different ways and combined in different ways. This is the texture. The texture, as you can see, is 4K by 2K. It's an HDR texture, but I am breaking it into the various channels, and I'm using those channels to create various effects. So I'm creating a nebula. So for example, you see this nebula right here is, I believe, the red channel. And for the other stuff, I'm creating other nebulas like this orange one. It's just a result of mixing in the other channels in various ways and lerping between different colors and stuff like that. And then the stars are as well a channel here, which is in the alpha, if I remember correctly. Yes. So if you go on the alpha, these are just stars. You can see that there is distortion happening. This is because this is a texture that is meant to be mapped on a sky dome, sort of like on a sky sphere. Sorry. So there's distortion happening at the poles, below and at the top. And this texture was generated actually using After Effects. Everything about this texture was made with After Effects. I happen to be a After Effects nut, so I know it quite well. So this is just a bunch of fractal noises, eventually with some like vector blur and stuff like that. And we just use some of the After Effects built-in tools for VR to unwrap this into a texture that can be then mapped into a sphere. Pretty standard stuff. Bornoa, I will try my best to post the archive of the stream here and on YouTube. So I encourage you to follow both here and on YouTube. I am recording, but I don't know exactly how the recording will look, so hopefully it will look good. Now, so the sky is pretty standard, nothing too fancy going on here. The lighting for the game is just one directional light, which is the sun. And again, this is moved dynamically. And one skylight. Now, here's an interesting problem with skylights. Skylights are usually used to sort of like give some of that ambient lighting to a model, sort of like to fake global illumination, because they usually rely on the capturing of the environment around them and stuff like that. You can also feed them a cube map, so they will use whatever cube map you throw at them. But the problem is that this cube map right here is actually, you know, the cube map of what a normal game would use. So you can see that this cube map right here has a very bright sun, has some greenish tone at the bottom, it's very blurred, and has the sky at the top, right? Fairly standard. But if I use this texture everywhere, when I went to look up, right? So when my camera is pointing up, now the reflections that are actually coming from below the buildings, let's say, that are at the top of the world, would actually be the reflections of the ground, so of the green part, instead of the blue part, which is the sky. So what we are actually doing is we have two sort of like two environment maps. We have this environment map, and we have this environment map. As you can see, this environment map is upside down. And what we're doing is, depending on the position of the player, depending on the position of the pawn, we are blending between those two maps. So that when you are at the bottom of the world, everything looks fine. And sort of like you're getting the bluish tones at the top and the greenish tones at the bottom. And when you are at the top, it's the same. You get the bluish tones at the top of the buildings, and you get the greenish tones at the bottom of the buildings, and the trick works. So that was a pretty cool trick that allowed us to achieve consistent lighting, depending on the part of the world. Now you can see that the lighting here kind of gets moody. Let me disable the fog of war once again. It gets kind of moody. It gets kind of purplish. But this is done on purpose for lore purposes, for gameplay purposes. But still, the bottoms of the buildings are pretty dark and the tops are pretty bright. And same thing over here. But this would not work if we did not do that trick. If without that trick, you would see that the top of the buildings would just be green, which would be awkward. Even though we are now, there is some sort of like suspension of disbelief, and we're doing it. We're doing the stuff that feels right rather than the stuff that would actually be realistic. So realistically speaking, the people over here would, like, the stuff over here would reflect whatever is at the top. But if this was a real world, this would actually be much, much, much bigger. It would actually have an atmosphere of sorts. So when you would go down here, you would actually see a blue sky, essentially. So you would see a blue sky, and so that's why we have a sort of like a traditional environment map. We don't have a blue sky because the world is pretty tiny, and because it didn't filter right. And because it just looking at the space is 10 times more cool. So when I'm over here and I'm looking upwards at the ring, especially if I do stuff like this, when I sort of like increase the field of view, just looking at the ring, looking at the fog, looking at the skybox, at the space, with this amazing soundtrack by Michael Gordon-Shapiro, it's just cool, right? This is just pretty cool, if you ask me. So that's why we don't have a sky. Anyway. So, lighting-wise, it's pretty simple. The only thing that is kind of weird about it is that the sun moves. So, the sun is essentially... The sun is not realistic in the sense that the ring is not actually rotating. The ring is static. If the ring was rotating, the sun would sometimes illuminate parts of the ring that are not useful, like for example the sea. So what we did was just simply, I just found 3 or 4 positions that I liked, and I just interpolate between them. So over here, you see that it's day, it's night, it's day again, and then it does some interesting movement, and then it's day again, right? You can see that it's never day up here. This is for lore reasons. And so we just concentrated on the portions where the most of the gameplay will take place in. So I think this is pretty much it for today. Next time I want to show you how we did the fog, especially how we did the fog of war, which is totally different again from the trailers on Steam and YouTube and elsewhere. And also how we did the clouds. Clouds and fog of war actually use a similar technique. It's sort of like a fake volumetric thing. I really wanted this to feel wispy and volumetric and feel like it's covering the world. But yeah, and you can see that we're doing a bunch of cool tricks with coloring everything black and white when it's in the fog of war. And also next time, I want to show you the cool effect that we have for when a building is built. So I'm just going to show them to you right now, and then I'm going to show you how they're done next time. When I place down a building, you see that the building sort of like pops up from the bottom of the world and appears as alongside this scaffolding. Now I'm going to try to do things properly and place 3 dice here. Oh man, this is one of those buildings. Okay, don't mind the column of dice. But you can see that the building is, like, something interesting is happening in the building where it's sort of like getting dark and then sort of like getting painted. The effect that we were trying to replicate is, if these were miniatures, if these like were props for a game of Warhammer, how would these be placed and painted? So if I place these 2 dice here, and I go and take a look at it pretty closely, you will see that sort of like it gets black and shiny, and then you can see that there are little like paint strokes that are appearing that are wet first and then get sort of like then they dry out, and then eventually the scaffolding disappears and the building is here. And so this is all accomplished in the material, just with one material that I'm going to show you next time. And also the other thing that I'm going to show you next time is the building destruction. Take a look at this. So if I destroy this building collapses on itself and then disappears. This is also done completely inside of the material. We could not do sort of like debris. We could not do like destructions and stuff with physics because we have the problem of the gravity. The gravity is all messed up. So what we did is simply do everything in the material. And I think it looks pretty fine. It has a VFX that accompanies it. Once again, I'm going to show it to you just with an unbuilt building. So the building collapses on itself and then goes down. This is all accomplished inside of one material, which I think is pretty neat. So I guess this is a preview of what is to come. Another thing that I'm going to show you next time is how we did the dice. These are actually all 2D, and this sort of like engraved effect of the die faces, which are meant to replicate actual dice, you know, actual acrylic dice, is all accomplished in the material. These are all like individual faces. They're just driven by textures, and it's all in the material. Nothing here is actually sculpted. And the last thing that I'm going to show you, another thing that I'm going to show you next time is how we did the pathfinding, which is happening over there, actually. So yeah, all in all, a bunch of cool stuff. This is Dice Legacy. Dice Legacy is on Steam. Go wishlist it. Just search for Dice Legacy on Steam. You can wishlist it. You see that there is a button over here, but it's unfortunately not pressable. But, oh no, a building has caught fire. One of my buildings has caught fire. I'll let him burn. But I would like to thank all of you for tuning in today. If you guys leave any questions on Twitter or Facebook, I will try to answer them. If you guys leave comments on YouTube, I will try to answer them if you have any questions. Otherwise, I will try to schedule another stream, possibly for next week, possibly at the same time. Thank you very much for watching. It was a pleasure to see all of you again, and I look forward to see you again. Take care.